Electrical feeders and subpanels are critical components of an electrical system, especially in residential applications. A feeder is a set of conductors that originate at the service equipment and supply power to one or more subpanels. Subpanels, also known as distribution panels or load centers, are secondary electrical panels that branch off from the main service panel. They provide a convenient way to distribute power to specific areas or circuits within a building. In a typical residential setting, the main service panel receives power directly from the utility company. From there, feeders carry the electrical current to one or more subpanels located throughout the house. For example, a detached garage, a workshop, or an addition to the house might have its own subpanel fed by a dedicated feeder. The size and type of feeder conductors required for a subpanel depend on the calculated load it will serve. The National Electrical Code, or NEC, provides guidelines for determining the appropriate conductor size based on the amperage and voltage requirements of the connected loads. This calculation must take into account all of the lighting, appliances, and other electrical equipment that will be powered by the subpanel. Voltage drop is another important consideration when sizing feeder conductors. Voltage drop refers to the decrease in voltage that occurs as electricity travels through a conductor over a distance. Excessive voltage drop can cause appliances to malfunction, lights to dim, and motors to overheat. To minimize voltage drop, it's important to use conductors that are large enough to carry the required current without significant loss. The NEC provides formulas and tables for calculating voltage drop and selecting appropriate conductor sizes. Grounding is another essential aspect of feeder installations. A grounding conductor is a dedicated wire that connects the subpanel's grounding bus to the main service panel's grounding electrode system. This grounding conductor provides the low impedance path for fault currents to flow back to the source, helping to protect against electrical shock and equipment damage. The size of the grounding conductor must also be determined according to the NEC guidelines, based on the size of the feeder conductors. Overcurrent protection is also required for feeders and subpanels. Overcurrent protection devices, such as circuit breakers or fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit. These devices protect the conductors from overheating and potentially causing a fire. The size of the overcurrent protection device must be carefully selected to match the ampacity of the feeder conductors and the connected load. It is essential to follow the NEC guidelines for overcurrent protection to ensure safety and prevent damage to the electrical system. In residential applications, it is common to use insulated conductors for feeders. These conductors are typically made of copper or aluminum and are covered with a layer of insulation to prevent accidental contact with other conductors or grounded surfaces. The type of insulation used must be appropriate for the environmental conditions in which the feeder will be installed. For example, conductors installed in damp or wet locations must be rated for wet conditions. The NEC specifies the types of conductors that are permitted for various applications. Installation methods for feeders must also comply with the NEC requirements. Conductors must be properly supported and secured to prevent them from sagging or becoming damaged. They must also be protected from physical damage by conduit, tubing, or other approved methods. The NEC provides detailed guidelines for installing conductors in various types of raceways and enclosures. When installing feeders, it is important to maintain proper clearances from other objects such as pipes, ducts, and structural members. The NEC specifies minimum clearances for conductors to prevent them from overheating or being damaged. It is also important to avoid running feeders through areas where they may be exposed to physical damage or corrosive substances. Proper labeling is essential for feeders and subpanels. Each feeder and subpanel must be clearly labeled to indicate its purpose and the circuits it serves. This helps to prevent confusion and makes it easier to troubleshoot problems in the future. The NEC requires specific labeling requirements for electrical panels and feeders. When working with electrical feeders and subpanels, it is essential to follow all safety precautions. Electricity can be dangerous, and it is important to take steps to protect yourself from electrical shock and other hazards. Always de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Firstly, determine the load requirements of the subpanel. This involves calculating the total amperage that the subpanel will need to supply to all of the connected circuits. Secondly, select the appropriate conductor size for the feeder. This is based on the calculated load and the allowable voltage drop. Thirdly, choose the correct overcurrent protection device for the feeder. This should be sized to protect the conductors from overheating in the event of an overload or short circuit. Fourthly, install the feeder conductors in accordance with the NEC requirements. This includes properly supporting and securing the conductors and protecting them from physical damage. Fifthly, connect the feeder conductors to the subpanel and the main service panel. Make sure to tighten all connections securely. Sixthly, ground the subpanel properly. This involves connecting the subpanel's grounding bus to the main service panel's grounding electrode system. Seventhly, label the feeder and subpanel clearly. This should include the purpose of the subpanel and the circuits it serves. Eighthly, test the installation to ensure that it is working properly. This includes checking the voltage at the subpanel and verifying that all of the circuits are functioning correctly. Ninthly, document the installation. This should include a record of the conductor sizes, overcurrent protection devices, and grounding connections. Tenthly, remember safety precautions. Always de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. Failure to adhere to NEC guidelines can result in serious consequences, including electrical shock, fire, and equipment damage. Therefore, it is important to consult with a qualified electrician if you have any questions or concerns about electrical feeders and subpanels. They can help you design and install a safe and reliable electrical system that meets your needs. Understanding the basic principles of electrical feeders and subpanels is essential for anyone working with electrical systems. By following the NEC guidelines and taking appropriate safety precautions, you can ensure that your electrical system is safe, reliable, and efficient. The NEC is updated every 3 years, so it is important to stay current with the latest changes. You can obtain a copy of the NEC from the National Fire Protection Association or NFPA. Additionally, many online resources and training courses are available to help you learn more about electrical feeders and subpanels. By investing in your knowledge and skills, you can become a more competent and confident electrician.